Good morning, guys. Today our topic is fuzzy logic, and particular topic is fuzzy sets. Now, this is our fuzzy logic. Okay, so we know the fuzzy logic was based on the ambiguity system. Means in our classical set there is the two limits, just 1 and 0, but in our fuzzy logics there is so many steps are there, just like 1 0, uh, uh, 1 means this is 100%, uh, point point 8 means 80%. In this way, up to this we may go for the so many steps. This is a fuzzy logic sets. For one example, uh, we can say the previous things, that is, if the quality of food is good, first we have to go for the basic concept, and then we are going for the exact fuzzy set. Say this is our food, this is our food, this is our food. Hope guys today screen is sharing properly. Okay. uh, if it is asked what about the quality, like what about the quality for the classical set, for the classical set, if I go for the answer, yes, this is good, that is 1. Yes, not good, not good, it is 0. Yeah, or the bad, but nothing in between, there is no nothing, quality is defined. But in case of the fuzzy set, in case of the fuzzy set, we may divide this quality, this question of the quality, in several stages, that extremely, extremely good, very good, average, or normal good, you may say, or not good, or bad. So in this way, this is the fuzzy logic set, because this is, if extremely good, that is 1, very good, that is 80%, satisfactory means 0.88. If you go for the voltage representation, then you can go this. Average means say 0.5, means 50%, and bad means that is 0. So if you go for this graph representation, then you can see this is good, this is for the good, that is 1, and that is 0, that is 0 for the bad. And if we go for the fuzzy logic set, that is fuzzy logic set, then we can represent in many way, that is this is the good, this is the good, this is the 80% good, this is the 50% good, or this is the 0. This is just like 0, I am just going, this is 50%, 0.5, this is 80%, this is 100%, or this is value is, say this is the 5 volt, say this is 5 volt, then there is the 1, there is 0 0.8, 0.5, and this is 0. In this way, uh, uh, in between this 0 and 1, fuzzy logic set can distinguish a separate different value, because this is not a simple one yes or no answer. This is the several decisions, several stages are required for your neural network, for your artificial intelligence. There is some decision making capability. So if you go for any decision making capability or something, in going to the perfection, then you don't go for 0 or 1, because in between 0 and 1 and so many things are omitted. Okay guys, that is the main difference between the classical set. This is the classical set, right? And this is the fuzzy logic set. This is the main difference. Now we are going for the fuzzy set, the innovator. Actually, in 1965, if Lotfi Jede first introduced this fuzzy logic set. Okay, this is the objective type question, and somewhere it is asked. So, if you go for the first, in 1965, in he first introduced this fuzzy logic set. Okay, and now what is the actual fuzzy logic set is doing? Actually, in previous, just like previous example, I am giving you the same example. Then we go for the fuzzy logic set and fuzzy logic sets functions, etc. Okay, membership function. So many things are there. First, say you have the 5 robots. Say you have the 5 robots. You have the 5 robots. This is robot A. This is robot B. This is robot C. This is robot D. Hope guys you can see this. I think you all can. Yes. Okay. And this is robot D. And now you can see the head of this robot. It is quite okay, and the eye sensor is very nice. This is the head is very high quality. Its hands is very high quality. Its leg is, this is the exact robot for the bipedalistic robot, and the body is for the D. But what is the fuzzy logic system? If you go for the, if you want to understand this, first fuzzy logic system going for the defuzzification. So defagification means just dismantle it. Just you can dismantle it. It's that is your head of robot A, that is B, that is C, that is D, and that is one quality. And this is hands. This is hands. This is also hands of this robots. Just dismantle means defagification. Then going for the legs. This is a wheel is added to this robot. This is legs and this is the body. So this is called the defagification. And now after then a fuzzy rule base will select on the desired requirement which things should be selected. Say I need some sensor based head, so this is selected. I need some robust quality of hands, then this type of selected. I need a robust quality of pedal, which pedal is added with some wheel, so this is selected. I need any type of body, so it may be selected this, but as per our rules we will select the high quality of body, so this is all selected. Then it will coming for the this is a fuzzification, sorry, this is fuzzification. This is fuzzification. Then it will come to the defuzzification. After selecting rule base, will select which things will be selected. If I told no, I no need of any sensor base as head, then any one of head which is very small, then this type of will be selected, not this. Okay, so as per the rule base, it will be selected. Rule base means according to the program, it will selected which things will be selected, which things will be not be considered. So in this way, this is selected. Then we will go for the defuzzification. Defuzzification means again it is arranged. This is defuzzification. In this defuzzification, look, selected is selected robot for head is just like this, just like this. This is the head. This is selected. This arms will be selected. And now as per the rule fuzzy rule base, it was selected this type of body structure of this robot. And as per the rule base, this bipedal legs also selected. So what happens, we will get a high quality of robotic structure. In this way we can get a high quality of robot. This is the fuzzy logic system. You can see this is the actual concept. And now we are going for the fuzzy logic, some algebra. Fuzzy logic sets mean there is some ambiguity. Okay, there is some ambiguity. Say the membership, there is some membership function. The membership function fully defines the fuzzy set, and this membership function provides a measure of the degree of similarity of an element. Okay, and membership functions are either it is chosen by the user arbitrarily based on the user's experience, say this is MF students by the users, and it could be different depending upon their experience, and or it may be designed using the machine learning modules. Easy, that is the artificial neural network, generic algorithm, etc. Now fuzzy sets. Fuzzy sets are generally three types. First one is the triangular shape. Second one is the trapezoidal, and third one is the Gaussian. That is triangular. The triangular shape looks just like this. In this way, this is the fuzzy logic triangular set. Then it is coming to the trapezoidal shape. Third one is, that is the Gaussian. That is looks like this. This is the fuzzy membership functions. Okay, so this type of fuzzy membership function is seen in your MATLAB simulation program. There you can find this type of membership function. And if we go for the fuzzy logic set operation, and after then we will discuss more about fuzzy logic set at the MATLAB programming actually. And there is some, in set theory there is some operation. First one is union operation, intersect operation, and complementary operation. Look, if there is this type of u-shaped sign, then you can find this is the union operation. In this, is if the u is just like this, then it is called intercept, and there is a complementary, that is this type of symbol is there. Say this is the set A, this is the set A, and this is the set B. If it is said that A union B means, A union B means there is a union sign is there. If it is told that A union B means the both sets, the elements are sets are common in this union of B, just like this, just like this. Both sets are union A and B. If it is told that A intercept B means which things are common only in B and B, A and B. Say in this picture you can find only these portions are the common for A and B. So this is the A intercept B. This is the A intercept B. This is the A intercept B. And if it is called the complementary of A, if this is complementary of A means A 1 minus A, okay, which is not in A. Say in this set, this is the set of X, in set of universe, this is universe of discourse, this is the X. In this position, this is the only A. So complement of A is this area, which is not within the A, or which is not apart from the A. Okay, so these three types of operations are there. One is, first one is the union operation, second one is intercept operation, third one is complementary operation. Now one by one we will go for example how is it performed. Okay, and now say a given set X to be the universe of discourse. This is, write down this example, you have to perform it in your examination also. X to be the universe of discourse, and set A and set B to be the fuzzy sets with mu a. This is the function mu a x and their respective membership functions. The fuzzy set operations are as follows. If it is called union operation, then we can write mu a union b. It means maximum of mu a x and mu b x. Say set A is comprised of say x1. For the x1 this is 0.5. For the x2, for the set x2 is the element which is 0.7. Say x3 is the element which is 0, and for the set B there is a x1, it is just like 0.8, x2 it is 0.02, and x3 is 1. So you can see this is the two separate sets, and within the sets x1 x2 are the elements, and these elements value are this. So we can find A union B means maximum of A or maximum of B. So it will find, if you go for A union B, then which one is the maximum? Look, in set A, x1 is 0.5, and set B, x1 is 0.8. Which one maximum? Maximum is 0.8. So in this case, we can find x1 maximum of A and B, then it will be 8. Okay. Now for the case of x2, for the x2 you can find for the set A that is 0.7, for the set B that is 0.02. Which one is maximum? Of course, uh, this one is 0.7 is maximum. So maximum of A and B will be selected. So this is, it will be 0.7. Now it is coming for the x3. Look, x3 for the set A, that is x3 is 0, and obviously for the set B x3 is 1. So x3 is 1 over here because this is the maximum. So this is the A union B operation. Guys, I think you can understand. This is the fuzzy logic sets operation. Okay, and then we are going for the intercept operation. And guys, if you have any question, you may ask me. Otherwise, I am going for the next topic. Look, this is the intercept operation. Section operation or intercept. Intercept or intersection operation means just which one is the minimum among these two. Say it is written in the just opposite of u and then b. Okay, means minimum of set A mu A, that is x comma mu b of x. In this way we can find the intersection of the intercept operation. Say you can find, look, in this way this is the minimum portion of this, which one common, this is the intercept. Now for the example, Write down this example. Say set A is comprised of x1 equal to 0.5, for the x2 for the set A is 0.7, for the x3 that is 0 for this set of A. And now going for the set B, x1 is 0.8, x2 is 0.2, and x3 is 1. Okay, so what will be the intersection operation of this A and B? You can find this is the mu A intersection B. So minimum of A and B. Look, in set A, x1 is 0.5, and in set B, x1 is 0.8. So which one is minimum? Minimum is 0.5. So here, that is, it is coming 0.5. Then x2 for the set A, this is 0.7, for the set B, that is 0.2. So minimum is of course 0.2, so it is coming 0.2 for the intersection operation. In set 3, in x3, look, here in set A this is 0, here set A this is 0, and set B x3 is 1. So actually it is coming 0 because 0 is minimum. So this is 0 is minimum. So this is A union A intercept B. And now if we go for the complement operation, now this is the fuzzy set operation, this is the complement operation. Complement operation is given just AC. Okay. Say set A is set A is, that is, x1 equal to 0.5, x2 equal to 0.7, x3 is 0. So complement operation means mu, that is given mu A x, complement means 1 by mu A x, 1 minus mu A x, A complement. Okay, so it is given, say, mu complement Cx, x1 is 0.5, so 1 minus 0.5 means, that is 1 minus 0.5 means, that is 0.5, it is coming 0.5, x1 is 0.5, that is 0.7, 1 minus 0.7 means, that is coming 0.3, so x2 is 0.3, 1 minus 0 means it is 1, so x3 is 1. So this is the complementary function. Okay, in this way we can find the fuzzy logic set algebra, and this type of examples are coming several times. And now we are going for the fuzzy set operation and fuzzy membership function. Which one is fuzzy membership function? First one is triangular membership function. In your MATLAB simulation, you can find this type of functions. this is mu a x, and this is a and b. This is triangular function. This is exactly 1. Okay, this is exactly 1. But this is the A, this is the B, and this is the C. So mu of AX is defined. First one is 0, means if the x less than or equal to A. Look, in this portion, less than or equal to A means this is 0. Up to this is 0. Then it is going to the higher range. And if it is coming A minus x minus A by B minus A in this portion, so if this A lies between x and B, x lies between A and B, it is coming x minus A and B minus A, this portion. Okay. And if C minus x means C to x and C minus B, it is happens if B less than or equal to C. In this portion, this function is coming. Okay, and in this function, in this portion, again it is 0. So again it is 0 if x greater than or equal to C, then it is 0. So from this equation you can find how the triangular function is working. So there is a different position and different value, but in the classical set there is only 0 and 1. If this is 1 and other portions also are 0, but in the fuzzy logic system there are the different position, and the different position the different value is assigned. So between the 0 and 1 there is a another two steps are there. The triangular membership function is specified by the three parameters, that is A, B, and C. You can see, and this A, B, and C represent the x coordinates of the three vectorized of the mu A, means this is the fuzzy set function mu A x in the area of the A. Fuzzy set A, that is the lower boundary, and the C, that is the upper boundary, where the membership degree is the 0, and the B center, whereas the membership function is 1. Others is 0 and this center is 1 only. So this is the difference between classical and the classical and the fuzzy sets. Now it is coming to the trapezoidal membership function. Trapezoid or trapezoidal membership function. Okay, a trapezoidal function looks like just like a trapezoidal, but you can see there is a four positions is there, because four edge is there, and this is one, this is one, and in this, look, this is the A, this is one edge is there, so this is the B, again this is the C, and again this is the D, because there is a four edge are coming, edge one starting, that is edge of peak and is going throughout, and this is the end pitch. This is the D. So the trapezoidal membership functions is specified by the four parameters A, B, C, and the D. And you can see the four position carries the four messages also. The u mu A of x you can find first one is 0, so 0 from where it is started, that is the a before a, this is all at the 0 position before reaching a, means we can say the x less than or equal to a is the 0. If so we can write down x less than or equal to a means 0. So these positions between 0 and the a, this is also carries the 0 message. And the next step from a to b, look, actually b is the, this point is b, actually this point is b and this point is c, b and c. So a to b, there is another message, there is another message, because voltage, if you go for the voltage representation, then you can find the another message. So because in binary there is a voltage level, if 5 is 1 then 0 or less than 5 is always count 0, but here you can find there is the 4 steps are there, actually 4 point is there, means 3 stages are there. So x minus a by b minus a, this position, if a less than x and less than b, and another you can write if it is possible if b less than x less than c. Okay, okay, this is one message, and this is also b to c, because these are identical, because c to b is also identical. Okay, so these two message, this position carries this two message. Okay, and now in between b and c, b and c carries also a message. So between the space of b and c you can find uh, b minus x by b minus c. This is also if x is less than c but greater than b, x is greater than b but less than c, so this area also contain a message signal. Okay, so this area contains this message, and otherwise other than the d this is also 0. So other than the d, if it is happened x greater than d, x greater than d. So you can find this trapezoidal membership function can carry four type of message, but in four type of message, two message are identical in the in respect to the voltage amplitude. Okay, and then we are going for the Gaussian membership function. This Gaussian membership function represents like a analog function. You can see the Gaussian membership function is just like a upper shape of sinusoidal waveform, just like this. It is it is changing by its time span. Say this is one Gaussian function, this is another Gaussian functions, and this is another Gaussian functions. Amplitude is same, but time spent is delayed. Look, this is in this way, this is varying. So Gaussian function could be varied in so many stages as per your requirement. You may change your shape. So this is also a Gaussian function. Okay. So Gaussian functions are given x, c, m. C is the center. Now here C is the center. Look, the center is same. All the centers of this here is same. All the center is the same. All the center are the same. C is the center and S is the wide. So wide is varying due to the this is varying, then it will be either carrying different of message. And this is M. M is called fuzzification factor. Factor. And now you can this is the one shape, another different shape, but the all are the Gaussian function. How it is different, and due to differentiation they carry the different message. Say this is C is the center, means all are in the 5, all in the scale point. This is 5, all are in the scale point at the point 5, all are in the 5, all are in the 5. So all C are 5, all C are 5 over here, all C are 5. This is fixed. And S is wide is S. Say in this case, S means wide, S is 2. In this case, say S is the range is very small from 2. So S in this case, say 0.5. Look here, S is very wide, very thicky, means this is very healthy. So this is S is 5. So you can see if I change this wide of this Gaussian function, then it became varies. And now as it is varies, so different Gaussian function carries different message. But M is for the fuzzification factor, M is always 2. Here M is always 2. Here also M is 2. Here is M is 2. Here is M is 2. So in Gaussian functions, only if I change this f means wide, then it will carry different message. So this this function carry some message, this function carry different message. So easily we can understood that this function carry this type of message. If it is coming to us, you can understand. Yes, say this is for the extremely good, this is average, say this is for the average, this is for say bad, and this is for only good. So if this is come, you can easily decide, yes, this message is conveying. So in this way, we can represent our fuzzy logic membership function, and it carries different of messages. So guys, if you have any questions, you may ask me regarding this. And this is available practically in simulation type for your MATLAB program. There you can find some this type of membership function, fuzzy logic rule base. Okay, and this fuzzy logic rule base you can program by your own logic, means and or this operation is available. So guys, if you have any questions, you may ask me, or otherwise I'm going to stop because the next class will be started. Next class already started. This is 52, 53. Okay, thank you. This is only less than 1 minute. If you have any questions, you may ask me. And in your exam, the fuzzy set operations, examples of the fuzzy sets operations are very much important. Everywhere this type of questions are asking: union operation, intersection operation, and complementary operation. And you have to represent with graph. Otherwise, it will not carry full credit.